Okay, so we're going to look at a graph right now to answer questions A through D. So the first thing we're going to do, and we'll just do this together, is find the change in y values from point S to T. So we're going to look at our y values, 9 and 3. Find the change. And it's 6. Let's do the same thing with our x values. We're going to find the change in x values from S to T. So 6 to 2. Okay, let me get the door. Having a bad day. All right. Part C. We want the ratio in the change of y values, 6, to the change in x values, 4. But then that becomes 3 over 2. But if we do rise over run, I already did that. Found the rise versus the run. Do we notice we get the same thing? So we're going to say they are the same. That's because if we recall from last year, there's something known as the slope formula, which describes the rule rise over run, which we know is the change in y over the change in x, with a formula. So we can take 2 points and we can call them one of the points x1, y1, and the second point x2, y2. And remember last year we called these things subscripts? It's just identifying the first x and the first y, the second x and the second y. And then we get a formula. And the formula has a specific variable that we use. M. M for slope seems kind of odd, right? Why not S? Well, we didn't kind of invent this or think it up. It was created or thought up way back when M was used for metry, which means measurement, and that's what they decided. So we want the change in y values. Typically it's y2 minus y1 over the change in x values, x2 minus x1. And this is what we call the slope formula. Okay. So this is what we're going to be practicing with today. So we can find slope graphically like we did yesterday, rise over run. We can also, if we have data points or points of ordered pairs, we can use the slope formula here. So let's go ahead and do that. So we're going to use the slope formula to find the rate of change for each of the questions below. Show all your work. So the thing is, we're going to, when we have these tables, we're going to assume they're linear functions. So we don't have to find every single ordered pair and compare it to every other one. That would take long. We're just going to assume it forms a line. You pick any two that you like. I prefer smaller numbers, so I'll stick with these. And so I'm going to pick one pair 0, 3, and the other pair 1, 11. And let's just find the slope. Let's go ahead and set it up. So I'll call the first pair my x1, y1, the second pair the x2, y2. And so I usually like to do this. Just set up a ratio with a difference in the numerator and denominator, plug in my numbers. So what number should I put in this position? 11. I want y values. And then 11, and then I'll put the other one, which is 3. And then let me zoom in a little better. And on the bottom, we're going to have our x values. That's what we want. Which one should go here? 1. Take away 0. So let's find the slope. 11 take away 3. What's that going to give us? Okay. 1 take away 0. What do we get? So it's 8 over 1 or just 8. Depending on what we're going to do, that'll work. Okay. So let's try this other one. This one's going to require a little more work. I can already tell because I have negatives. So let's do the same thing. Let's set up a ratio with subtraction. It doesn't matter how we set this up. So this is going to be x1, y1. This will be x2, y2. And let's find the difference in the y values. So we want -4, that y value, minus -3. And now let's find the difference in the x values. So we want x2, which is 3, take away -7. And we have, I'm going to just go ahead and switch these to addition. So I'm going to do keep, change, flip. And then keep, change, flip. And let's see what we get. So I've got a slope of -4 plus 3, 3 plus 7, -1/10. Okay. All right. Go ahead and try the same thing with 3 and 4. 3 and 4. So work with your table partners. And let's do this. And see how, this is what I got. Check and see if I did this correctly. So I picked obviously. What happened?